Hello CS50, I'm George Newman, I'm 19, I'm from London, England, and for my final project I decided to make an R library that makes it a lot easier to calculate and analyse deviations from straight line missions. When you look at the map to the right, you probably just think that someone's drawn a blue line across Google Earth, right? Wrong. That line is the route that my friends and I walked across Dartmoor this summer. Inspired by GeoWizard and the Fieldhouse Boys, the aim of a straight line mission is to walk across somewhere in a straight line. But how straight was the line that my friends and I walked? That's what I created this R library to find out. My library consists of 4 functions, the first of which reads your route from a GPX file. The start of my GPX file is shown to the right, and you can see my location every second is recorded in these segments. My function loops over every coordinate using the XML2 library and saves them to a data frame that looks like this. The second function in my library reads the data about the line you are trying to follow, either from a GPX file or a 2x2 matrix. Like last time, this loops over every coordinate in the file, but unlike last time, this only takes the first and last coordinate in the file. Once again, this uses the XML2 library and outputs a data frame that looks like this. The next function in my library calculates the shortest distance between each point and the line. It does this by first being given the line and route data frames as calculated by the previous 2 functions. It then loops over every point in the route data and calculates the smallest signed perpendicular distance between the point and the line. A visual representation of this process is to the right. This function also calculates the distance that each point is along the line. This is useful in later analysis. I could have used basic linear algebra to perform these calculations, but instead I used the geosphere library. Note that the line data is actually optional, and if it isn't provided to the function, then it will just assume the start and end points of the route file are the same as the start and end points of the line. This then adds 2 columns to the existing route data frame shown here. The last function in my library calculates what's called the Burdell score, which is a commonly used method for calculating line straightness. The maths behind it is scrolling by on screen now and can also be found at this link. In essence, it outputs a value between 0 and 100, which indicates how closely you followed the line. It takes the route and line data as inputs, but in addition there's an experience level. So in conclusion, the functions in my library can be combined as shown. I think the real power in my library though is what you can do with the data it generates. For example, you can do rating analysis, summary statistic analysis, plot histograms, graphs, pie charts, do whatever kind of analysis you want with the data. But overall though, that's it from me. Thanks for watching.